Okay, back to a graph question. This will be a little bit of review and a little bit extra because we're going to put the second derivative into it. First of all, this is the graph of the derivative of a function. So it's really important because these three questions we're going to answer, the x-coordinates of relative minimum, relative maximum, and point of inflection, need to be based off the first derivative. So now that I know I'm looking at that first derivative, I'm going to, instead of answering the questions right away, I'm going to justify the answers. It will be so much easier. So for number one, a relative minimum happens when the derivative, remember everything's going to be in terms of derivative now, when the derivative goes from negative to positive. A relative max is when the derivative goes from positive to negative. And a point of inflection is when the derivative, well, it's all based off concavity. So we know a graph is concave up when the derivative is increasing. A graph is concave down when its derivative is decreasing. A point of inflection happens at changes of concavity. So a point of inflection always happens when the derivative changes from increasing to decreasing or vice versa. So those are my justifications. The answers are going to be easy now. So relative min, the derivative goes from, here's the derivative, goes from negative to positive. Well, here's negative, here's positive. So it's switched from negative to positive right here. So x equals -4. It has a relative max when the derivative goes from positive to negative. So here's positive, positive, positive. And it stayed positive. So it never did change from positive to negative. So there are no, because this never happened. Point of inflection happens when the derivative changes from increasing to decreasing or vice versa. So the derivative is increasing, going up from here all the way to here. It's concave up. Then it starts decreasing. It goes to concave down. So you don't have to mark this, but it was concave up here because the derivative is increasing. Concave down here, from here to here, because the derivative is decreasing. And then right here, the derivative goes back to increasing, so it's concave up. So from concave up to concave down, making this a point of inflection. From concave down to concave up, making this a point of inflection. Now, don't say the point is -2, 5. That's just the point on the derivative. We don't know the point on the graph. That's why we're just looking at x-coordinates. We do know that it did change at x equals -2. So that's the x-coordinate of a point of inflection is x equals -2 because the derivative changed from increasing to decreasing or vice versa. And then again at x equals 1. So hopefully that helps with the graphs. They're pretty simple if you understand and remember the justification.